Mark your quiz. Here we go. It says, suppose a forklift raises, I'm thinking lifts. You know what? The work is going to be, well, work is always force times distance, but in this case, we said it's going to be mgh because the force that you have to lift with has to cancel out mg, and we'll call it a height. So it's going to be 688 times 9.8 times 2.4. Mr. Dueck, what about that 45? I don't use time for work. I'll use that probably in a part B. Or maybe I just gave you some extra numbers. I don't know. Let's see. It's going to be 688 times 9.8 times 2.4. And you get 16,000. I'm going to go 16,200 if that's okay, but you could write as much as you want. 16,200 joules. And 1 mark, all or nothing, because this is a straight plug and chug. B, how much power? Well, power is going to be work over time. So it's going to be, I'm lazy, my answer button divided by 45 seconds. Answer button divided by 45 seconds. And I get 359.6. I'm going to say 360 watts. 359.6. I would take a half mark off for 359.5, or if you're missing the units. I would also say both for this equation, work equals mgh, it has 4 variables. I'm comfortable giving you any 3, find the 4th. I'm hoping you can get the h by itself or the m by itself if you need to. For this one here, it has 3 variables. Same dealio. In fact, Bruce, what's number 2 want me to find? Oh, sorry, number 2 is a different question. Number 2, how much work will I do if I carry an 8.8 kilogram bag 9.3 meters forward? Remember, this is the piggyback demo that we did. When you carry something forwards, how much work are you doing on that object as a number exactly? Nothing. Why? Because you're not changing. If you're moving at a constant speed, that object is not changing its energy state. It's not gaining or losing potential energy. It's not gaining or losing kinetic energy. That's really the best reason I can tell you that the work is 0 is because of the work energy theorem. Now, Megan's looking at me, Mr. Dueck, why do I get tired then? Okay. Your body, while you're walking forwards, while you're holding it, in the same direction as gravity, you have thousands of little muscles that are stretching and relaxing, stretching and relaxing, stretching and relaxing. Each of those is burning food energy. It is burning calories, and that's why I'm picking my words carefully. I should have said, how much work will I do on the object? If I'm being really nitpicky. You are going to burn energy. That's why you can burn calories when you go for a walk. Okay. This one, Bruce, what's number 3 asking me to find? Time, you say. Now, I got a bunch of, you know what, just for old time's sake, I did that. I've got a bunch of different ways to find time. You know what? I saw lifts, I see a mass, I see power. I said, I think I'm going to start out by going that. Where is the t right now, Bruce? On the, yeah. Well, we've seen this before. I'm going to multiply the t to the top, and I'm going to divide the power. And so I'm going to get time equals work over power. Which work? What word did I underline, Bruce? What's the work done in lifting? 3 letters. It's on your formula sheet, or it's from number 1. What's the work we do in lifting, folks? Malika, what's the work we do in lifting? In fact, I think this is the one I always asked. What? Yeah, I think this is the one I always asked you. So it's going to be mgh over power. And now I'm good. It's going to be 1,200 times 9.8 times 17.5 divided by 15,000. How much time will this take? I have no idea. 1,200 times 9.8 times 17.5. There's only one thing on the bottom, so I don't need brackets. You get 13.7 seconds. Is that correct? Anybody else? Am I wrong? Yes? Yeah, okay, sorry. I just saw people smiling. Nod, yes? I'll go 13.7 seconds. If you got that, 2 out of 2. Otherwise, I would give you a half mark if I saw time is work over power. I would give you a half mark for mgh over power. I would give you a half mark for the numbers and a half mark for the answer. What is the potential? Okay. gravitational potential energy. So it's going to be 50 times 9.8. And then I wrote that 4 times 10 to the 2 is 400. I unscientific notationed it because it was less writing. 50 times 9.8 times 400. You get 196,000 joules? One mark. All or nothing. What's the change? Ooh. Huh. What's change in anything, Owen? I think you were the one I kept hitting this with the other day. Well, maybe not. Final minus initial. So it's going to be the change in potential energy is going to be the final minus the initial. Now, the initial is 196,000. What's the final? I guess that's going to be 50 times 9.8 times 200, or 2 times 10 to the 2. It's going to be 50 times 9.8 times 200 minus answer button. And I get negative 100. Oh, no, I get negative. Is that right? Negative 98,000. What's the negative telling me? I will be fussy. You do have to have a negative. What's the negative telling me? Did the object gain potential energy or lose potential energy? Lose. That energy had to go somewhere. Where did it go? Yeah. In a perfect world, lots of it also went into bumping air molecules out of the way, giving them energy. You've all felt when a truck goes past you on the road really fast, all of the air molecules pushing against you. That's all energy that was also taken from the truck. But as always, unless the question says include air resistance, we're going to be in our magic physics world where air resistance is ignored. So negative 98,000. I will be fussy. Joules, all or nothing. Skateboarder approaches a hill with the speed the total mass is, coasts up the hill. You know what? I think if I imagine this, I'm seeing something like that. I'm seeing a change in height, a change in speed, and a yucky curvy path. I think I want to use conservation of energy. I think since we're starting on the ground, I can do that. Oh, and comes to a stop, I can do that. So I'm going to get a half mv initial squared equals mgh final. And as, oh, did I need to give you the mass of the skateboarder? Turns out I didn't. It looks like, in fact, the m's cancel because there's one there and one there. If you put it in, you're still going to get the correct answer. As far as I'm concerned, I can either give you the height and ask you to find the speed, or I can give you the speed and ask you to find the height. Either of those you should be comfortable getting by itself, as it were. Here they wanted the height, so I'm just going to go divide by g. And I'm going to get h equals vi squared over 2g. What happened to the 1, Mr. Dueck, from the 1/2? Kanan, will multiplying by 1 change anything? So you can't make me write that. It's going to be 10.5, don't forget the squared, divided by 2 times 9.8. And I get 5.62? 5.63, sorry, yes? 5.6, 5.625. I'm going to go 5.63 meters. What if there was a little kid holding the hand of this skateboarder on their own skateboard? They would go to the same height. Suppose an object has a kinetic energy of 1,000. It speeds up until it's 4 times faster. Okay, if we're 4 times faster, how many more times energy, kinetic energy, will we have? This is that squared. It's going to be 16,000 joules. It's going to go from 1,000 to 16,000. The only way you can do it is to realize it's squared. I didn't give enough information otherwise. Water slide. Okay, they want the height of the water slide. They are saying ignore friction, so we're going to ignore heat. Okay, I see a change in height, change in speed, yucky curvy path. That's a job for conservation of energy. I guess here the final potential energy is 0. And it says starting from rest, so the initial kinetic is 0. We want to get the height by itself. Okay, it's going to be mgh initial equals mv final squared over 2. I wrote it like that because it's a little cleaner. Did I give you the mass of the person on the wall? I did. Did I need to give you the mass? Nope. And I guess to get the g by itself, I'm going to divide, sorry, to get the h by itself, I'm going to divide the g. G2 looks yucky. I'm going to go 2g. That looks better. And I'm going to get the initial height is v final squared over 2g. It's going to be, what was v final? 16 squared all over 2 times 9.8. And I get 13.1, 13.06, I'll go 13.1 meters. If you got that, 4 out of 4. Otherwise, I would give you 1 mark if I saw that. I would give you 1 mark for getting the h by itself, 1 mark for the numbers, and 1 mark for the answer. Ooh, how much energy was lost to heat? Okay, so now we're going to go kinetic initial plus potential initial equals kinetic final plus potential final plus heat. Now, potential final, still 0. Kinetic initial, still 0. I want to get the heat by itself. I'm going to minus that over. I'm going to get heat equals the potential energy initial minus the kinetic energy final. It's going to be mgh initial minus a half mv final squared. Do the m's cancel this time? No. So, okay, heat is going to be, what was the mass? 63? Times 9.8 times, I guess I got to use my answer. I'm going to write 13.1, but I'm going to use my answer button, or I would use 13.06. Minus 0.5 times 63 times 8 squared. By the way, on a water slide, you don't lose as much to heat as you do to pushing the water molecules along. That's why you don't exit the bottom of the water slide at the same speed as if you jumped off the water slide and hit the ground. So in real life, for a water slide, I should have said how much energy was passed along to the water molecules, because you may have noticed when you exit a water slide, you're pushing a lot of water in front of you. Okay. Some of you, oh, okay. 63 times 9.8 times answer button minus 0.5 times 63 times 8 squared. I get, did you get, oh, 6,050? Is that correct? 48 joules. If you got that, 4 out of 4. Otherwise, I would probably go something like this. 1 mark for that, 1 mark for that, 1 mark for the numbers, 1 mark for the answer. So this quiz is out of 4 plus 4, that's 8, plus 1, that's 9, 10, 11, 12, 13, 14, 15, 16, 17. It is out of 18. I did add it correct. Can you give yourself a score out of 18, please?